Okay, now we're going to be getting into something that typically trips up a lot of students. Not because it's particularly difficult, but because there's just a lot of information that's going to be coming at you at once. And this is taking those ideas encapsulated in the production function and putting it into different cost curves. Now, these are curves that you will have to actually draw. You see examples of them already out there on the graph on this slide. So uh, we're going to go over a few ones that you will definitely have to draw and others that you have to know conceptually. Um, as you draw them, these will become extremely important as we go into different market structures. So pretty much from here on out, everything you do is going to be repeated and repeated and repeated a lot. So if you don't get it, you need to make sure you talk to me, and we'll work out a time to make sure that you understand the stuff. So let's delve a little bit deeper into this. First of all, when you're drawing it, the y-axis is going to be price, or if you're just looking at cost curves, you can put it as cost of each unit. The quantity is going to be in the x-axis. In reality, the easiest way to do that is y-axis P, x-axis Q. That's the simple, easy way to do it because that's going to carry through for everything. Now, to understand how we get to those cost curves that you saw on that graph, we first have to understand total costs. And there are three types of total costs. One, fixed cost, two, variable costs, and you've met both of those before. Those added together get you your total cost. So this is adding together all of the variable costs and adding together all of the fixed costs get you your total fixed cost and total variable costs, and adding both of those together get you your total cost in general. So important things to know, the fixed cost doesn't vary as you have a change in output, which makes sense. It's fixed in the short run. In the long run, you can change it, but in the short run, it will always stay the same. So these are payments to fixed inputs. So your fixed input being your factory size, like your rent, that is a fixed input. So that is your fixed cost, paying your rent. A variable cost, usually we're going to talk about it in terms of labor. So as you hire more workers, that's a change in variable cost. You need to hire more workers in order to produce more goods. So this gets you the idea that your fixed cost plus your variable cost equals your total cost. And this will change as you move along different output levels because your variable cost changes at different output levels. Now, those are important to know conceptually. However, you're not going to be graphing them. You might be shown a graph of them, but they're not particularly important for analysis. The most important part of our analysis is going to be marginal cost. Almost everything we do is more important when you look at it in terms of the marginal. So marginal cost is just your change in total cost divided by your change in quantity. As with other marginal things that we've done, the change in quantity is almost always going to be 1, but do pay attention just in case it isn't. So as you move a change in output, what is your change in total cost? That is your marginal cost. You can also look at it as, since your total cost is your variable cost plus your fixed cost, and your fixed cost doesn't change, that means that the change in your variable cost is the same as the change in your total cost. So if you're given variable cost and not given your total cost, you can actually come up with your marginal cost just based off of that. So if you are moving from a quantity of 1 and your variable cost is 10, and your next your quantity of 2, your variable cost is 15, then your marginal cost is 5. That's how you figure that out. Your marginal cost at a quantity of 2 is 5. So what you will see with the marginal cost is that it's like check shaped. It's swoosh shaped, if you will. So it's because it's going to decline at first due to specialization in your inputs. So you're going to have increasing returns from those first couple of inputs you put in normally. Beyond that, you have diminishing returns. And once you have diminishing returns, that's when you're going to have your marginal cost increase. Now, it might seem like a small bit to talk about, but it actually shows up kind of frequently on the AP test. So if you ever need to determine where diminishing marginal returns set in, it's always where marginal cost begins increasing. That's an important thing to keep in mind. Now, when we talk about average cost, these are any of the curves you see with A in the front of the name. So ATC, AVC, in some cases AFC. It just means you take the total and divide it by the quantity. That's it. Anytime you see average, it's total divided by quantity. Now, there's two that we normally graph. It's your ATC and your AVC. Your AFC isn't really too important in our analysis. And we'll talk about why in just a second. But first, ATC is your average total cost. It's your average total cost. Sometimes you'll see it as the unit cost, per unit cost, average cost in general. Any of those phrases, they all mean the same thing. So you just take your total cost divided by the quantity. Your average variable cost is just your total variable cost, divided by quantity. Your average fixed cost, or your AFC, is going to be your total fixed cost divided by your quantity. So if you really think about it, since your total cost is your fixed cost plus your variable cost, your average total cost is your average fixed cost plus your average variable cost. So these are equations that you're going to have to know. They're not particularly difficult, but you do need to have them memorized. You do need to know them off the top of your head, and you need to know how to mix and match them in order to get different things. For instance, if you have average variable costs and you have the quantity, and you want to figure out your marginal cost, you can do that. You multiply the average variable cost by the quantity to get the total variable cost. And if you have that for two different quantities, then you can figure out the change in that total variable cost. This is a very, very common type of question on the AP test. So you're going to need to make sure that you know how to do that. We'll do some practice with it as we go. Now, we don't frequently graph the average fixed costs because it doesn't really tell us much. The fixed cost itself, the total fixed cost, is the same always. So as you add more and more quantity, your average fixed cost will decline. So it will always be downward sloping. This, once again, doesn't tell us much in terms of analysis for our firms. However, it's an important concept that shows up frequently on the AP test. It is not uncommon for them to have a question of which of these curves will constantly decrease as quantity increases. And the answer will be average fixed cost. Another thing with average fixed cost is that it is representative of the space in between your average total cost and your average variable cost. So if you notice, your average total cost, of course, will always be above your average variable cost. That's because it is always going to be greater since it's the variable plus the fixed. The space in between the two is representative of the fixed cost. You notice when it's drawn correctly, the space should be getting smaller and smaller as you increase quantity. Now, if you don't draw it that way, are they going to take off points? No, I've never seen them do that. But important things are that you do need your ATC U-shaped and you need your AVC U-shaped. So they should be ATC above, AVC below, both U-shaped. Now, they're both U-shaped because two effects are happening. First, you have the spreading effect. So as you have a larger output, your greater quantity will cause your AFC to fall, leading to a lower and lower average total cost as you have a greater quantity. However, once your diminishing returns effect comes in, so your diminishing marginal returns, once that starts setting in, the larger the output, the greater the variable, and therefore you will have a higher and higher and higher AVC, which pushes up your ATC. Now, if you're wondering why the AVC is downward sloping at first, that's because of the same reason why your marginal cost is downward sloping at first. It's just that short time of increasing marginal returns. So you do need to know these two effects and why the curves are shaped they are. That is an important part of this unit, and it does show up frequently on the AP test. Now, the relationship between your marginal cost and your average cost is that your marginal cost is always going to intersect the U-shaped ATC and AVC at their respective minimum points. Now, I've been saying a lot that this stuff shows up on the AP test, and trust me, this is one of the biggest things to show up. Your marginal cost must always intersect your ATC and the AVC at their minimum points. I can't stress this enough. They will take off points if you're graphing on a free response question if you don't include this, and there's going to be there's going to be frequent multiple choice questions about this. And they will be phrased in several different ways. Some of them might say something along the lines of, your average cost is falling as long as, and then it's your marginal cost is less than your average cost. Because if you notice where ATC is downward sloping, your marginal cost is below it. So your marginal cost is less than your ATC. Same thing works for AVC. As your AVC is downward sloping, your marginal cost is less than it. As soon as it crosses that plane, as soon as marginal cost intersects it, that's when your variable cost and your average variable cost and your average total cost will increase. So that's an important thing to remember as well. Marginal cost is greater than your average, then your average will be increasing. And if you're wondering, why does this work? The answer is math. If you just do the math out, you'll see that this is always the way it works. Now, of course, there's more complicated explanations, but you don't have to get into those. All you have to know is this basic relationship. And if you're able to show it using math, all the better.